Hi, welcome back to our continued discussion on the derivative of natural log. So for example number 8 here, we want to take the derivative of the natural log of the absolute value of cosine. Now, why is cosine an absolute value? Well, that comes from the domain of cosine. Remember, there are values of cosine. There are values of cosine that are less than 0. So we have to make sure that they're positive, so we make it absolute value. Tomorrow we're going to start talking about the antiderivatives, and that becomes way more important for us. But now we're not too bad. So now if I want to take the derivative, I'll use y prime this time. This is a chain rule. There's my outside. And the derivative of the natural log of cosine is just going to become 1 over cosine of x times, looking at the derivative of the inside, well, what's the derivative of cosine? Negative sine of x. And this becomes negative sine of x over cosine of x. Therefore, we can say the derivative is negative tangent of x. Now, this is kind of an interesting one because this leads to our first antiderivative. What would be the antiderivative of tangent of x? Well, it's just the opposite. So if the derivative of natural log of cosine is negative tangent, then the derivative of antiderivative tangent should be the negative natural log of the cosine of x plus c1. Don't forget the child. Okay? All right. So let's see this as a differential equation. Suppose that y is equal to x, natural log of x minus 4x, is a solution to this differential equation. We want to show that. So we need something. We need x, we need y, and we do need y prime. So we need the derivative. So let's go do that. So we're going to take the derivative, and that's going to become our product rule here. The first times the derivative of the second plus the second times the derivative of the first minus 4. And if I clean that up, we just get 1 minus 4, so we get natural log of x minus 3. Be careful, I would put parentheses there so we don't think that that's one long quantity. Plugging it in, remember my function says x plus whatever y is, x natural log of x minus 4x minus x times the derivative, which we said was natural log of x minus 3 equals to 0. Cleaning this all up, we would get x plus x natural log of x minus 4x minus x natural log of x plus 3x equals 0. And of course the natural log of x is cancel. X is negative 3 plus 3, and those all cancel. We do get 0 is 0. Alright, that's it. We're done. We're done. But I want to go over, so if you're done, if you're good, go and do the homework, practice it. But I want to take a few minutes, and we're going to take a look at just some other examples of the derivative of natural log of x. Some more examples here, okay? Reason, because this is kind of a big topic for us. So let's say I have something like y equals, let's say here, the natural log of the square root of x plus 3 over x cubed. And I want to take this derivative. Now, if I don't use the properties, man, this is pretty nasty. Okay, that's a chain rule. If I don't use it, my inside derivative is going to be a chain rule, a quotient rule. It's really bad. So, by using my properties, I can rewrite this. Use those properties. They help make the problems easier for us. If I use my properties, I can write this as 1/2 natural log x plus 3 minus 3 natural log of x. Now, I'm not done with the derivative yet, but I can take it now. The derivative then, therefore, would be 1/2 times the derivative of natural log 1 over x plus 3 minus 3 times 1 over x. And there's my derivative. Now, if I did not use my property, no properties, ready? Oh, watch this one. The derivative of natural log is 1 over all of this times the derivative of the inside is quotient rule, low, d high, remember that's 1/2 x plus 3 to the negative 1/2 minus high x plus 3 to the 1/2 d low 3x squared times about over the bottom squared, x to the 6. And I still have to clean this up. Oh, no negative exponents, no complex fractions. It's a nightmare. You'd be like, no. Okay? So use those properties. So let's take a look at a few more that we can use. Y equals, and I'm going to show you a really cool application of natural log 2. Y is equal to the, let's say here, natural log of x times the square root of x plus 3. So for something like this is just my product rule. So we have these product rule. We can't expand it because, there we go, make it look like this. So this is going to be our product rule. So dy dx would equal, this becomes the first times the derivative of the second. It's negative 1/2 plus the second, the square root of x plus 3 times 1 over x. And of course, the only thing you have to do is just put this on bottom. We would get natural log of x over 2 times the square root of x plus 3 plus the square root of x plus 3 over x. Now, watch the difference. What if I wrote it this way? The natural log of x times the square root of x plus 3. Well, that's a different problem because they're all inside our natural log. It's a natural log of something. This wasn't. They were independently multiplied together. So in this case, I could use just straight up power it out and take the derivative. I would have a product rule on the inside. Or I can use the properties, Luke. Use the properties. Taking the derivative, dy dx. Oh, don't take the derivative yet. Sorry. Rewrite it. This becomes the natural log of x plus 1/2 the natural log of x plus 3. So when I take my derivative, 1 over x plus 1/2 times 1 over x plus 3. Much easier. Be careful. These are different problems, so they're not going to be the same answer. Now, why do we like natural log? Let's see here. Watch what we can do. This is one of the coolest things that we can do. Let's say I have something like y equals, let's see here, the square root of x minus 3 over the sine of x. And I want to take this derivative, but I forget all my rules. I can use something called logarithmic differentiation. Now we're going to talk about this later on, but I can go and introduce it to you. What you do is you can take the log of both sides. The natural log of y equals, and if I take the natural log here, I can now use my properties. I will get 1/2 natural log x minus 3 minus the natural log of the sine of x. Now remember, this has to be an absolute value. We saw that in our video earlier because there are values for sine that can be negative. When I take the derivative, what's going to be the derivative of natural log of y? Now you got to be careful. There is an implicit differentiation here. We're going to get 1 over y times dy dx. It's our implicit differentiation. Equal to 1/2 times 1 over x minus 3 minus 1 over sine of x, chain rule, times cosine of x. Don't forget our chain rule. And therefore, I can now say dy dx equals, this is 1 over 2 times x minus 3 minus cosine of x over sine of x. Don't know what that is. But then I got to multiply that by y. And if I replace my y, I would get 1 over 2 x minus 3 minus, I'm just kidding, that was cotangent of x. And what is y equal to? The square root of x minus 3 over sine of x. It's called logarithmic differentiation. We're going to see that later on. It does have a lot of good uses for us, something you want to know when you go to college. All right, I hope you guys enjoyed the videos. I will see you all later. Have fun and see you soon. Bye-bye.